Alright, here we go. Gases and solution concentrations. Alright, so we're going to briefly hit and remind you about what happens to the solubility of gases when temperatures goes up, and then we're going to talk about calculating concentrations. Yes, math is back. Alright, so we'll remember solubility of gases in liquid solutions. As the temperature of a solution rises, gases generally become less soluble. Alright, so as temperature goes up, gases goes down. This is actually can be seen realistically. There's these things that happen during the summer sometimes in ponds and in lakes and sometimes rivers too, where if you're talking about water, oxygen's the gas, and oxygen actually will dissolve. The gas will dissolve in water, and in the water we have, oh, that's horrible. I was going to draw a fish. That was the worst fish ever. There we go. There's my fish. Alright, we have lovely fish. That's a bigger fish. We have lovely fish in our water. And the fish need the oxygen to breathe. But what can happen is temperatures can get really, really hot. And for gases, as the temperature goes up, the solubility goes down. And so all this oxygen that could be dissolved in the water, alright, this is actually starts coming out. Alright, so you'll have less and less oxygen in the water for the fish to breathe. And if that happens so much, the fish can actually die. They don't have enough oxygen in the water, and it's called a fish kill, and it happens sometimes. And so this is a realistic application of this, and why it's important is to look at temperature levels in water, especially if your job's a fisherman or something like that, and all the fish are dying because of no oxygen. You've got problems, and you got to figure out what's causing the rapid rise in the temperature of the water. Alright, so as temperature goes up, the solubility of gases goes down, it decreases. Remember, it's the opposite for solids. As temperature goes up, we can dissolve more solid in it. Alright, so we're going to talk about concentrations mostly in this video. Concentrations measure of how much solute can dissolve in a specific amount of solvent. So how much can dissolve in there? If I look at these picture of these 2 cups of tea, which one would you think is the higher concentration? Well, this is usually easier. Most people get this. Well, the one that's darker is the higher concentration of tea, right? The one that's darker. This is easy to do when you're looking at something that has color to it, right? The darker it is, the more dark the color is, or the vibrant the color, the higher the concentration. But most things you come across in the chemistry lab and chemicals you come across are actually clear colors. It's dissolved in water, it's clear. How can you look at something that's clear and know if it's a higher or lower concentration? Right? So, calculation you need to be able to do is something called molarity. Alright, molarity. Molarity is huge in chemistry. You got to be able to do this. Here's what you have to do. Alright, the formula for it is this, and you need to write it down somewhere. Molarity is equal to the moles of solute divided by liters of solution. Moles of solute divided by liters of solution. Okay, very important. Now, molarity is a capital M, so capital M is molarity, that's the symbol for it, okay? And remember, it equals moles of our solute over liters of our solution. So we're looking for moles over liters is equal to molarity. Yes, moles is back. Keep that in mind. I told you before when we did all those phlegm charts that units are very, very important. This is the same thing. You got to have moles divided by liters, okay? If you're given grams, all right, you can't plug it in here. You'll have to convert it to moles. If you're given milliliters, you cannot plug it in here. You got to convert it to liters. So your units are so important here. If you do not convert these and give them into the right unit, you're going to be wrong. Let's look at a calculation here. All right. Remember, this is molarity is equal to moles of solute over liters of solution. And I'm going to change up my question here and put solution here. Alright, an intravenous, an IV, stuff you get at the hospital, solution contains 5.10 grams of glucose, C6H12O6, and 100.5 milliliters of water. What is the molarity of this solution? Alright, I already started you off to make sure you're paying attention to our units. Alright, I gave you grams, and I gave you milliliters. That doesn't work to find the molarity. So what can we do? Well, we learned that we can convert grams to moles. So if I have 5.10 grams of glucose, I don't want grams of glucose. I want moles of glucose. Mole and gram together, my number for mole is 1. Grams is from the periodic table. That's right, making you go back there. If you remember carbon, and if you don't remember, it's okay. Get a periodic table out. All right. Carbon is 12.0 on the periodic table, and we have 6 carbons here. So I'm going to multiply that by 6 in just a second. Hydrogen's 1.0 on the periodic table, and we have 12 hydrogens here. And oxygen's 16.0 on the periodic table, and we have 6 oxygens here. So I'm going to multiply those numbers. Okay. Grab a calculator out, please. 12 times 6 is 72. 12 times 1 is 12. And then 6 times 16 is 96. And then hopefully remember we're going to add all these up. So 72 plus 12 plus 96 gives us 180.0. And that's going to go here. Alright, so this will help us find our moles. So 5.10 divided by 180. Alright, times 1 gives us 0.0283 moles of our solute. Fantastic, we have moles. Let's look here. 100.5 milliliters. Uh-oh. That's milliliters, we want liters. Alright, some of you learned how to just move the decimal place. Some of you didn't move it correctly. Alright, I like to do a flim chart with it. I have 100.5 milliliters. I want to convert milliliters to liters. There are 1,000 milliliters for every 1 liter. So when I plug this into my calculator, I get 0.1005 milliliters. Oops, sorry, not milliliters. Milliliters canceled, right? Liters. Here we go. 0.1005 liters. Now I can plug it into my equation. 0.0283 moles divided by 0.1005 liters. 283 divided by 0.1005, and we get 0.282 molar solution. Notice I put a capital M there. I've got moles over liters, which is molarity. And there is my answer for this one. Now, I went ahead and started you off with a sort of difficult one. Sometimes I'll just give you moles and liters and you just plug it in. Alright? But you need to know this formula. So molarity equals moles divided by liters. Okay? Alright. Using the same equation, different kind of question though. You will have to prepare a solution for molarity. And so, how many grams of CaCl2, calcium chloride, would you be dissolved in 1.0 liters of a 0.100 molar solution of calcium chloride? How many grams? Well, my equation is molarity equals moles divided by liters. Let's figure out what I have here right now. Okay? I have liters as 1.0 liters. And I've got the molarity this time. What I don't have is my moles. So, I've got this is equal to, we don't know how many moles, divided by 1.00 liters. So how do I solve for x? Well, I just multiply over. So x is going to be equal to 0.100 divided, times 1. This makes it easy. 1.00. Now, if you remember, molarity is, this big molarity means moles over liters. And so when I multiply this over, and I'll just show it down here, I'm just going to rewrite molarity as moles over liters. And I am multiplying times 0.100 liters, which is equal to x. Liters top and bottom cancels, and my unit that's left is moles. So we got 0.10 moles. Fantastic. I know my moles. Well, look what the question asks. How many grams of calcium chloride would be dissolved in this much solution? So, I now need to convert because my unit doesn't match up to my question. Alright, I've got moles of calcium chloride. I want to cancel out moles of calcium chloride, and I want to go to grams of calcium chloride. Gram and mole together, moles 1, grams from the periodic table. For calcium, your mass is 40.1, and there's only one calcium. For chlorine, your mass is 35.5, and there's 2 of them, which gives you 71. Add them up. Alright, and you get 111.1. Alright, we're going to multiply on top, divide on bottom. So I got 0.1 divide times 111.1, and you get 11 point, this is equal to, sorry I'm putting it down here because I ran a room, 11.1 grams of calcium chloride. Alright, so another one that everybody needs to know is diluting a solution. Alright, what is dilution? Well, first of all, diluting a solution, if you've ever diluted something, that means watering it down. Lots of times people think about it as watering it down. So making it weaker. Alright, there are times where I got a really strong solution, a high molarity in my stock room where I keep my chemicals at, and I actually need a lower molarity to give to y'all. And so instead of ordering a bunch of different chemicals at different molarities, it's really cheaper to buy one that's really high concentration, a high molarity, and adding water to it to dilute it, and then give it to you. So there's an equation you need to know. It's M1V1 equals M2V2. And when you do these equations, I'll always give you a starting and ending molarity or a starting and ending volume, and you got to find one of these variables. So remember our equation is M1V1, that's molarity and volume to begin with, equals M2V2. What is the volume in milliliters? Alright, and actually I'm just going to say what is the volume. Alright, we're just going to change this up a little bit. What is the volume of a 3.0 molar Ki stock solution? Alright, that would be needed, that you would use to make 0.300 liters of a 1.25 molar Ki solution. Alright, the question I get all the time from students is how do you know which one's M1 and M2? You got 2 molarities here. Well, M1 is always going to be your highest number with molarity. So find your highest number, that's the 3.0. So 3.00 molar. Now, how do you know which one is V1 and V2? For this one, it's not much hard, a little bit. Just see which molarity goes with which volume to make 0.300 liters of a 1.25 molar solution. These go together. So since this is your second molarity, then this volume must go with it. And so what we're trying to solve for is V1. Alright, so to solve for V1, I'm going to divide, oops, that's supposed to be 0.30, divide my 3.00 molar over to get V1 by itself, so I'm dividing this over. V1 equals, you're going to see my molarities cancel, leaving with liters. So 1.25 times 3.00 divided by 3, alright, gives me 1.25 liters. And I now use my M1V1 equals M2V2. Alright, that is all for the CP classes, and now we're going to just go for the honors classes. You have 2 more calculations to do, so if you're watching this video, honors, this is for you. Alright, another way to calculate volume, or concentration, is something called percent by volume. This is actually kind of used out there. If you've ever looked at rubbing alcohol, your rubbing alcohol will have like 97% on it. And what that's telling you is 97% of that liquid that's in there is alcohol and 3% is water. Hydrogen peroxide says 3% hydrogen peroxide. 3% is hydrogen peroxide and 97% is water. Okay? And so how they get that is they do something called percent by volume. And percent by volume, here's the equation, is equal to the volume of the solute divided by volume of solution times 100%. Look carefully at what that says. Solution. Keep that in mind. Alright, let's just use it to calculate something. What is the percent by volume of ethanol in a solution that contains 35 milliliters of ethanol dissolved in 115 milliliters of water? Alright, what's the percent by volume? Percent by volume is equal to the volume of your solutes. Alright, the ethanol is being dissolved, so it's my solute. So 35 milliliters of your solute. Divided by. Alright, here's the hardest part on these. This says this is dissolved in water. Is water a solution? The answer there is no, it is not. Water is a solvent. And so, what is a solution? Well, a solution is a solute and a solvent. Notice they gave us the solute and the solvent. So to know the solution, you add these up. Now, why this is hard for many students is that sometimes I'll just actually give you the volume of a solution. I might say 35 milliliters of ethanol is dissolved into 100 milliliters of solution. Okay? But other times I'll give you the solvent. So you just need to be able to pay attention to know which one that is. Alright. Notice also all these are in milliliters, so that's good. The milliliters are going to cancel out. So when I add these two together, 35 plus 115 gives me 150 milliliters of solution. Okay, so I added these up to get 150. Plug this in. So my percent by volume is equal to 35 divided by 150 times 100. And with two significant figures, I get a 23% solution. Okay? Alright, one more calculation you need to be able to do, and that's something called molality. Molality is moles of solute divided by kilograms of, this time it is solvent. This is abbreviated. This is actually like a cursive M or an italicized M. So lots of times you'll see me do it like this. So I won't do like a regular M. I'll kind of slant it some to solve for molality. Right? So you're starting to see a lot of things. You're starting to get a lot of different variables here. You got capital M's molarity, lowercase slanted M's molality. All right? So you got to be careful to make sure you are paying attention to what you're given. Alright, molality. Once again, molality is equal to moles of solute over kilograms of solvents. In a lab, a student adds 4.5 grams of sodium chloride to 100 grams of water. Calculate the molality. Well, sodium chloride is going to be my solutes. Water is going to be my solvents. This is 4.5 grams, but oh, I want it to be moles. That's right, flum chart. So 4.5 grams of sodium chloride. I want to cancel out grams and go to moles. 1 mole. Grams from the periodic table. For sodium chloride. For sodium, it's 23. For chlorine, it's 35.5. Add them up, and you get 58.5. So 4.5 divided by 58.5 gives you 0.0. 7 moles of sodium chloride. Alright, divided by kilograms of solvent. Uh-oh, I gave you grams. So we need to convert that. For every gram, how many kilograms is there? Well, you can do this one way. You can either do the decimals or not. I'm going to say that I know there's 1,000 grams for every 1 kilogram. So this is going to count to be 0.1000 kilograms. Plug this in. Molality is equal to 0.077 moles divided by 0.1000 kilograms. Alright, so 0.077 divided by 0.1000 is equal to 0.77 molal solution.